Welcome back to our video module on statics. Today what we'd like to do is take a look at some of the practical applications of what we've learned. Many of you may have heard the word trusses before. Trusses are a common use of taking multiple beams and putting them together in such a way that they can support good loads. And you've probably seen them all over the place. We're going to spend this module talking briefly about what makes them work, why they're so useful, and how we can understand them better. So what I have here is a truss, on a road, and it looks maybe like it might be it looks like a road, not a railroad. And notice something, you'll see triangles. And when you look at trusses, that's what you see almost all the time. Over here we have triangles oriented in such a way that we call this a K-truss, and I imagine you can figure out why we call that. There's all sorts of ways that we can combine trusses. I'd like to combine triangles to make trusses, and as you explore, you'll probably find all sorts of different examples of those. Today, to get an understanding of trusses, we'd like to take a look at one. By definition, a truss is any time you have a two-force member. By two-force, that means that there are only two forces acting on it, usually tension or compression at the ends, equal and opposite. Two force members joined by a pin. Now, in practice, we don't really use pins. We rivet things together, we weld them, but for purposes of calculations, we think of them as pins. So it's a two-force member and a pin that defines the truss. Now, generally, we see lots of triangles because of this, and the reason is if you take a triangle, you can take three pieces of three members, put them together, put pins at the corners, and it is stable. It can support load. Take a moment. Try and do that with any other number of sides, 4, 5, that type of thing, and you'll see that the whole thing would collapse if you had pins. So this is the reason, one of the fundamental reasons why triangles are so pervasive. Now, let's take a look at this truss right here. Right here, let's use a brighter color, orange. Now you're looking at this and you're saying, okay, Brett, so I hear I'm supposed to have two force members. You've drawn out the truss. Okay, great, great. There it is. But there's a problem, because look at this bottom member. That's not a two-force member. You have this one long member, and let's draw out the forces. You have a supporting force here, and maybe it's also pushing this way. You have a supporting force on the other side, and then you have a force in the middle, and so it's going to try to bend it. It's going to be some sort of moment. Well, what we do in this case is we don't build them so that this comes together and is not a pin. We see this, each of these segments, as a pin's location. Now, if we see each of those as a pin location, all right, now we're looking at something that makes a little bit more sense. We have two triangles that are joined. They're pinned together, and that is how we're going to carry the load. Now, one of the interesting things about trusses that I'd like to get into right off the bat, because it helps you start thinking about them correctly, is let's imagine our truss. And I'm going to try and draw this as carefully as I can. We're going to apply a load to this truss. We're going to apply a load right up here. And, we have a support here. Maybe we have a rolling support here. That's often how we'll do it. We're going to apply a load right here. And so the first thing you're thinking is, okay, well, you're applying a load. Let's do a free body diagram. So let's do a free body diagram about this point. About that point, we have the load coming in. Okay, and then we have from one member, we have some force. From the right member, we have some force, and from the bottom member, we have some force. And so we need to balance these out. We sum in the x direction to 0, we sum the y direction to 0, we figure it out. It's no big deal. We know how to do this. However, there's a problem with this idea in this setup. The problem is this. We'll call this point A and this point B. Let's do a free body diagram of point B. Point B, here we go. We have the left member, we have the right member, and we have the member going from A to B. Now, the problem with this is if we're pinning something, we can sum in the x direction, we're going to get 0. Sum in the y direction, we're going to get 0. Well, if we sum in the y direction to get 0, that means that segment between A and B, it can't take any force. It might take a moment for that to settle in. But the segment between A and B can't take any force because of this area right here. We need to sum in the y direction to 0. There's only one member, so that member must be 0, which means up here, the same member, that must also be 0. This brings up an interesting characteristic of trusses that at about any point, we need to be able to balance the forces to 0. Now, that said, you might ask, well, what's the point of that even being there? Now, those of you who are careful also ask, well, that may be, but Brett, when they're using the bridge, the force isn't applied up there. The force is applied at the bottom, and in fact, those arrows are somewhat misleading because of the way that a bridge is built. The force is applied here, force is applied here, and force is applied here. As a truck goes over, the forces are concentrated only at the pins. And we'll talk about that in a minute or two. So if that's the case, then our real truss, what we'd really see is like the first truss, but our applied force is now at the bottom. And well, that may not seem like a lot of sense, or seem like a big difference, but if we go through and draw our free body diagrams, we see one big difference. Let's look at our free body diagram around B. Now at B, you have the applied force going down. You have, and we'll call that force applied. You have coming in from the left, you have a force coming in from the right. That's this member. And then finally, you have some sort of force A, B, going away. Now we can sum that, which means the force of AB is the applied force. So you can see that what happens here is this force, when applied at the bottom, gets transmitted to this member. This force right here, the force in member AB, gets transferred to here. And we could just draw a free body diagram. Here, let's move down a little bit. We could draw a free body diagram around A, and you'd see that you have the left member, you have the right member, and then you have force AB going up. We can just sum in the y direction, and we'll find out what the forces are in all the members. Now, that said, there's two more details that are probably worth covering right now, and that is, what do we do about members that the weight of a member? So let's take a look at this member right here. Okay. Let's say you get a problem where the weight of the member matters. What we do is we apply half the weight to the left pin, half the weight to the right pin, and that's how we take care of their own weight. Finally, one of the things that you'll notice is that I applied the force when a truck goes across here only at the pins. Now that could be a problem because unless you're a kangaroo, a truck isn't going to jump from one pin to the next. Instead, what they do is we'll look at this from the top. Here's our truss, and if you look at it at a slight angle, you might see something like this at a slight angle. And at the areas that are pinned, like let's say point 1, at this area right here, this and here, which correspond to here, here, and here. At each of those pins, they run a stringer that goes all the way across. They run some sort of support. Maybe it's its own truss. Maybe it's some network. Maybe it's a beam, whatever it is. And it's supposed to carry the weight of everything that's on top of here. There's not a whole bunch of small ones that carry the load. rather there's these three big ones that carry the bulk of the load. They put it on the pin, and then to just make sure they cover everything, they'll connect these with members that go like this. And then what happens is as your truck moves across, it's going to move its weight more and more from this member. Halfway through, it's balanced between these two. And then as it gets closer to this member right here, as to this stringer, this force is going to decrease, and it's going to move its force all the way across. The important thing being that it's going to apply that force at each of the pins. I hope that gives you a good feel for how trusses act, what some of the fundamental rules are for them, and gives you a landscape for moving forward as we do some problems with them. Thank you, and I look forward to seeing you soon.